Hello friends, in this session we are going to see the questions from trains and boats and streams. The 90% of the times the question in the banking exam is going to be about trains and boats and streams. Now both the topics, they are typically formula based topics. And you just have to consider different formulas for different situations. Like in case of trains, we have to consider the formulas train crossing pole, train crossing platform, trains crossing each other. In case of boats, you have to see upstream and downstream formulas. So if you are good with those formulas, then you can solve any type of questions they ask in the banking exams very, very conveniently and easily. And that is what we are going to see, how the formulas are formed and how to remember those formulas and how to use those formulas for different questions. So let's first start with the trains. So in case of trains, there are different situations that you have to tackle with, but to understand those situations, your concepts of relative speed should be good. So that is what we have seen in the last video, what relative speed is. Just as a quick revision, because we are going to use it quite a lot here, you just have to consider two situations, object traveling in opposite direction and object traveling in the same direction. So if there are two objects traveling in opposite direction with speed SA and SB, their relative speed is SA plus SB. Basically, in opposite direction, the relative speed is the addition of speed. And if they are traveling in the same direction, SA and SB, with speed A and speed B, then their relative speed is the subtraction of both. So if they are traveling in the same direction, the relative speed will be the subtraction of both. So just these two concepts you have to again reuse in the topics like train. Now in the trains, as I said, there are specific situations. Trains crossing a pole, platform, a moving person, and trains crossing each other. So for every different situation, we are going to form the formula here. And once the formula is formed, you have to remember the formula as it is. You don't have to ever then draw the diagram or imagine the situation based upon the question. You just have to see train is crossing what, and you just have to recall the formula and use the formula directly. But here we are going to form those formulas first. So first thing is train crossing a pole. So if I say a train of length 100 meters is passing with the speed of train is say 25 meter per second. How much time this train is going to cross a pole? The question is, how much time this train is going to cross a pole? Now, first thing is, if you're a fresher, you've never saw this topic, train crossing a pole, then naturally, one doubt might come that, let's say this is a pole. This is a pole, and train is coming from this direction. So this is a train. So one might wonder, if I give you a stopwatch and I ask you, please count the time this train is going to cross this pole. So one might wonder that when should I start the stopwatch? Should I start it when the train is here? Or should I start it when the train is here? Or should I start this train is here? So when should I start the stopwatch? Or what the exact meaning of train crossing a pole? So you should start your stopwatch when the train's engine portion is in line with the pole. At that point, you are going to start the timer. And as the train starts passing this, when the tail portion just passes the pole, at that time you should stop the stopwatch. And the time taken by train to cross a pole means the time taken by train to move from this position to this position. So whatever the time taken for the train to move from this position to this position would be the time taken by this point to go from here to here, because meanwhile that this point has moved from here to here. So what is the time taken? Time taken is distance upon speed in terms of time speed distance. So what is the distance traveled by this point? The distance traveled by this point is this much, which is equal to length of train. So distance traveled is length of train, and speed of this point will be speed of train. So as I told you, friends, whenever you see the question regarding trains crossing a pole, now you don't have to imagine this situation. You don't have to draw the diagram. All you have to do is recall this formula for train crossing a pole. So whenever the question is about train crossing a pole, just have to write down time taken will be length of train upon speed of train. In this situation, length of train is 100, speed of train is 25. So time taken is going to be 4 seconds. Time taken to cross the pole is going to be 4 seconds. Okay. Now second situation. Again, same thing. Length of train we can say is 100 meters and speed of train we can say is 25 meter per second. Second part can be asked is, what is the time taken to cross a platform of length? Now length of platform say is 200 meters. Length of platform is 200 meters. What is the time taken by the train to cross this platform? So again, say this is a platform. So when should we start the timer, or when the train starts crossing the platform will be the position when the engine portion is at one of the end of the platform. So at that point, you should start your stopwatch, and then the train passes, and the position when the tail of the train just crosses the platform, at that time you should stop the stopwatch, and the time taken to cross the platform would mean the time taken by train to go from this position to this position. That means the time taken by this point to move from here to here. So what is this distance traveled by that point? This distance is nothing but length of platform plus length of train. This is length of train and this is length of platform. So point has traveled from here to here means the distance traveled by point, time is distance upon speed. So distance traveled by that point is length of platform plus length of train, and speed of that point is going to be speed of train, because only one object is moving. So relative speed is not yet into the picture. Just have to consider normal formula, distance upon speed. So length of platform is 100. Sorry, length of train is 100. Length of platform is 200. Upon speed of train is 25. So 300 upon 25. The answer is going to be 12. 12 seconds. Time taken to cross the platform will be 12 seconds. This is the condition number 2. Let's see another situation. For the same train, length of train, let's say again 100 meter, and speed of train is, let's say again 25 meter per second. Now, how much time it is going to cross, it is going to take to cross a person, a moving person? With speed of the person is say 5 meter per second. Speed of person is 5 meter per second. Now, person if also moving, then there can be two conditions. Person is either moving towards the train, or they are moving in the opposite direction, or they are moving in the same direction. So if the person is moving in the opposite direction, that means the person is going in this direction and train is coming from this direction. Now this train needs to cross this person. What is the time taken to cross the person? Now, because both the objects are moving, it now becomes little difficult to imagine what exactly crossing means. So that is what what we do is we consider the person steady. Whenever you are going to use the relative speed, you assume the person to be steady. So let's say the person is steady here. So steady person is like the pole. So if the person is like the pole, that means the time taken to cross the person would be the time taken for a train to go from this position to this position. So what is the time taken? It is going to be distance upon speed. Distance is this much. That is equal to length of train. But because we have considered the person to be steady, the speed that we have to consider here is going to be relative speed, because we assume the person to be steady. And what is the relative speed? When objects are moving in opposite direction, the relative speed is the addition of both. So speed of train plus speed of person. Now this becomes the formula for us when a train crosses a person which is moving. And then you can just put the figures. Length of train is 100. Speed of train is 25. Speed of person is 5. So 100 upon 30. It is going to be 3.33 seconds. 3.33 seconds. But if the person is moving in the same direction, then you can say, if the person is moving in the same direction, for example, this is the person, this is train moving, and the person is also moving in the same direction. So you have to consider again the person to be steady. The train will go from this position to this position. The distance traveled will be this much, which is equal to length of train. So time taken in that case is going to be distance upon relative speed, because we assume the person to be steady. The distance will be length of train, and the relative speed will be speed of train minus speed of person. Because objects are going in the same direction, there will be the subtraction of speed. So this becomes our formula in case they are moving in the same direction. Okay. And then if you are given the same figures, then you can just solve it. Length of train is 100. Speed of train is 25. Speed of person is 5. So 100 upon 20 is 5 seconds. So answer in that case would be 5 seconds. And there are last two situations where, let's say the first train has length of train 100 meter and speed of train 1 is again 25 meter per second. What is the time taken to cross another train with length of train 2, say 300 meters, and speed of train 2, say 15 meter per second? Again, here two conditions can evolve. One, they are moving in the opposite direction. So if their trains are moving in the opposite direction, this is the first train. It has to cross the another train coming from the opposite direction. So if both the objects again are moving, it is hard to imagine. So what we do is we consider the train 2 to be stable, any of these train to be stable. So crossing the train would now mean like crossing a platform, because we are considered the train to be steady. So another train when passes, and when the tail portion passes each other, that time we say the train has crossed the another. So what is the distance traveled? Distance traveled is this entire, which is nothing but length of train 1 plus length of train 2. So time being distance upon speed, distance is length of train 1 plus length of train 2. But because both objects are moving, we have to consider the speed to be relative speed. So speed of this point, we have to consider st1 plus st2. The relative speed will be addition, because objects are moving in the opposite direction. So this becomes our formula in case trains are moving in the opposite direction. So time taken to cross each other will be length of train 1 plus length of train 2 upon speed of train 1 plus speed of train 2. So length of train 1 is 100. Length of train 2 is 300 upon speed of train 1 is 25 plus speed of train 2 is 15. So 400 upon 40, the answer is going to be 10 seconds. But if the trains are passing in the same direction, then now you must have known the time taken is going to be distance upon same thing, relative speed. This time, the distance will be again the addition. Length of train 1 plus length of train 2. Because even if the another train is going in the same direction, like this, if you are considered that as a steady, so this train is going to cross and going to go to this position. So distance travel will be still same, length of train 1 plus length of train 2. But the relative speed here is going to be st1 minus st2. The difference, because they are moving in the same direction. So that becomes the formula for us in case trains are going in the same direction. So time taken to cross. And if you use the same figures here again, so 100 plus 300 upon 25 minus 15. So 400 upon 10, The answer is going to be 40 seconds. In that case, the answer will be 40 seconds. So only these many situations, if you understand, and if you remember this formula, as I said earlier, you never will have to draw the diagram, never will have to imagine the situation, just will have to use the formulas as they are. So of course, we'll have to do little practice based on this. So let's do some practice. Let's start with some easy question, then we'll go to the RBI level question. Okay, we'll come back to these questions later. First, let's see this one. It's SBI question. Okay. Okay, let's start with this one. Length, train A of length 120 meter can cross a platform of length 240 meter in 18 seconds. Ratio of speed of A to B is 4:5. So you know, time to cross a platform. So just recall the formula. Time to cross a platform was length of train plus length of platform upon speed of train. So time is given. So just write time as 18 seconds. Length of train is given 120. Length of platform is given 240. So we can calculate the speed of train, and that will be train A because it is a train A. Speed of train A you can calculate from this. Speed of train A is going to be easily 360 upon 18, that is 20 meter per second. Now the ratio between speed of train A and speed of train B is given as 4:5. So to maintain this ratio, as you can see, if this is getting 5 times, this must also get 5 times. That means speed of train B is 25 meter per second. Now they are asking how much time the train B will take to cross a pole. So you know, time to cross a pole is length of train upon speed of train. In this case, length of train B upon speed of train B. So length of train B is to be calculated. Length of train B to be calculated. Time is given. So time is 12. Length of train B is to be calculated. Speed of train B we just calculated, that was 25. So that gets us length of train B is 12 into 25. That is 300 meters. So the answer here is going to be 300 meters. So as you can see, I didn't draw the diagram. We didn't even have to imagine the situation, who is going where and or. You just have to use those basic formulas that we derived. Let's see next. A 175-meter long train P passes a pole in 8.75 seconds. Train P passes another train Q traveling in opposite direction in 60/7 seconds. If length of train Q is 225 meters, then in what time train Q will pass train P when they run in the same direction? So crossing a pole, crossing another train in opposite and same directions. 3 formulas we are going to use. So I hope you recall those formulas. If not, pause the video, go back and just write down the formulas and then solve the question. I'll directly use the formulas. Time to cross a pole is 8.75 is equal to length of train, which is 175 upon speed of train. So we can calculate the speed of train from here. Speed of train is going to be 20. So speed of train is going to be 175 upon 8.75. That is equal to 20 meter per second. This is speed of train P. Now train P passes another train Q traveling in the opposite direction in 60/7 seconds. So time to cross another train in opposite direction is length of train 1, which is 175, plus length of train 2, which is given 225, upon speed of train 1, which is we just calculated 20, plus speed of train 2. So speed of train 2 means speed of train Q. From here, we can calculate speed of train Q. All you have to do is that becomes 400 upon 20 plus speed of train Q. This 0 will get cancelled with this 60. And then we can do the cross multiplication. It gets us 120 plus 6 STQ is equal to 280. 6 times STQ will be 280 minus 120. That is 160. So speed of train Q is going to be 160 by 6 or 80 by 3. 80 by 3 meter per second. Now you just have to calculate how much time they will take to cross each other when running in the opposite direction. So time to cross each other in the opposite direction is length of train 1, which is 175, plus length of train 2, which is 225, upon speed of train 1, which is 20, plus speed of train 2, which is 80 by 3. Sorry, subtraction. Same direction is subtraction. So now here the bigger figure is going to be this one, because this is approximately 27, 26 point something. So when we write subtraction, the big figure should come minus the small figure. So that becomes 400 upon, that is 20 by 3. 20 is 20 times 20 into 3 is going to be 60 seconds. So the answer here is going to be 60 seconds. Easy? Let's see one more. Length of train A is 400 meters and length of train B is x meters more than the train. If speed of train A and B is equal and they cross the pole in 16 seconds and 24 seconds respectively. So first of all, train A having length 400, it takes 16 seconds to cross a pole. So time to cross a pole is length of train upon speed of train. In this case, the train is A. So speed of train A. That gives us speed of train A as 400 upon 16. 16 2s are 32, 16 5s are 80. So 25 meter per second. So that means speed of train B is also 25 meter per second because it says the speeds of both train is equal. Now train B crosses pole in 24 seconds. Time to cross a pole is equal to length of train, in this case is B, upon speed of train, which is 25. So that means length of train B is going to be 25 into 24, that is 600 meters. Now they are asking how much time train B will take to cross a 400 meter long platform. So time to cross a platform is length of train, which is 600, plus length of platform, which is 400, upon speed of train, which is 25. So 1000 upon 25 is 40 seconds. So time to cross the platform for train B is going to be 40 seconds. So I hope you now understand why formulas only to be remembered, why you don't have to draw, because in exam, neither you have time to draw the diagram, nor you require, because the questions will be so much formula based. Okay, let's see one more. Okay, this is now RBI Grade B question. A train traveling at 100 overtakes motorbike. Overtakes means obviously from the same direction. Overtakes means same direction. So time to cross a moving person. Motorbike is like a moving person. You don't consider the length of motorbike anything as compared to the trains. So it's like a person. So time to cross a person is length of train upon speed of train minus speed of person. Speed of train we already know, it's 100. Minus speed of person we already know is 64. But this will be into the kilometer per hour because this is also kilometer per hour. This is also kilometer per hour. But this is in seconds. And the answer should be in meters. That means we have to convert this into meter per second. Yesterday we saw how to convert kilometer per hour into meter per second. All you have to do is multiply it with 5 upon 18. So let's multiply this bracket with 5 upon 18. That gets us 40 is equal to LT upon, this is 36 upon 18. That means 2 times of 5. That means 10. So length of train is going to be 400. And that is what it is asked. What is the length of trains in meters? The answer is going to be 400. The questions are going to be easy. Sometimes we make those questions difficult first by not actually understanding what is expected of us. And secondly, not playing the unit conversion game properly. Here, if you upfront convert these and this into meter per second, unnecessarily you are going to consume a lot of time because this is also not multiple of 18. This is also not multiple of 18. So converting those into separately into meter per second is going to unnecessarily cost us time. But if you realize their subtraction will also be into kilometer per hour, and directly if you try to convert, that will be easily converted, because the difference is 36, which is a multiple of 18. 18 can naturally cut the 36 with 2. So that means practice is required in the right direction practice. The approach for the practice should not be only to solve the question or to gain the knowledge, but to reduce the calculation time and the trouble that we pass through. Solve it very, very comfortably without having any unnecessary undue pressure upon us. Okay, let's see one more. A train Pawan Express of length TAT running with the speed 108 crosses a platform of certain length in 37 seconds. So you know the formula. As I told you earlier also, if you don't recall the formula, write down the formula at one page and then try solving this question, at least when you as long as you're a fresher. Because every time I'm not going to write the formula here, I'm directly going to use it. But while using, of course, I'm going to say everything that it required. Time to cross a platform is length of train plus length of platform, which we don't know, upon speed of train. But here also, the speed of train is in kilometer per hour. This is into meter. This also will try to get into the meters, and this is into seconds. So this also should be into meter per second. So we convert it into meter per second by multiplying 5 by 80. This is 18's 6 times, that becomes 30. 30 into 37 is 1110. So length of platform will be 1110 minus 380. It is 0, 3, 7. 730 meters is the length of platform. Now another train, Tufan Express of certain length, crosses the platform in 42.6 seconds. So time to cross a platform is equal to length of train. This is Tufan Express, so I'm writing T. Length of train T plus length of platform we just solved for upon speed of train. Speed of train is 90. Again, 90 we can convert into kilometer or meter per second. That will be 5 into 5, 25 meter per second. So directly I'm using the figure 25. So 25 into 42.6 is going to be 1065 is equal to length of train Tufan plus 730. And if you subtract this from it, length of train Tufan is going to be 335 meters. Now we have to calculate how much time they will take to cross each other in opposite direction. So time to cross each other in opposite direction, the formula is length of train 1, which is 380, plus length of train 2, which we just calculated 335, upon speed of train 1. We already have converted that. That was 30. 6 into 5, 30. Plus speed of train 2, which we already converted as 25. So basically it is going to be 715 upon 55. Both are multiples of 11. So 11's 6 times, 11's 5 times, 11's 5 times. 65 by 5 means 30 seconds. The answer here is going to be 13 seconds. Easy. Let's see one last from this category, and then we'll go to ports and streams. This is also a question from RBI Grade B. It says length train A 240 meter long crosses a platform double its length in 24 seconds. So if I say length of train is x, length of platform is going to be 2x. Find the approx time taken by train B. This is train A. Train B is 200 meter long to cross. Time taken by to cross B. Train crossing each other in opposite direction. So first formula you are going to use to cross the platform. So time to cross a platform is equal to length of train plus length of platform upon speed of train. Now speed of train A, we don't know. Okay, length of train is given. So 240 is given, and this is going to be then 480. So 240 plus 480, this is going to be 720. So speed of train we can calculate from here is 30 meters per second. 30 meters per second is the speed of train A. Now, how much time it will take to cross B running with this speed? So let's convert this quickly into meter per second. So 108 kilometer per hour to meter per second is 5 by 18. That is going to be 30 meter per second. So this is 30 meter per second. So time to cross each other from opposite direction is length of train 1 plus length of train 2 upon speed of train 1 plus speed of train 2. That is going to time to cross each other from opposite direction. So that becomes 440 upon 60. So 44 upon 6 is approximately 7.7. So answer is going to be 7 seconds. Answer is going to be 7 seconds. Easy. Now let's see another concept for the day, that is the boats and streams. So as was the case in case of trains, where we realize once you derive the formulas, when you understand how the formulas are formed, then you don't have to use the formula. You don't have to use the figures. You just have to use the formula every time. Similarly, here in case of boats also, we are going to derive several formulas with the situations, different situations. And once you realize the formulas, then you can just forget the situations or the figures and stick with the formulas that we have formed. So first of all, the terminologies are important, because the different terminologies we are going to use in case of boats. So imagine this is a river which is steady right now, steady, and you are passing by it through a boat. So when you are passing from a boat in a steady water, whatever the speed of yours is called as SB. So SB is, for all future references, would mean speed of boat in steady water. Okay, so whenever we are going to derive the formulas in terms of SB, you must understand what SB exactly means. SB would all the time mean speed of boat in steady water. Now imagine the water also starts flowing in the same direction with the speed SS. Now, SS for all future references would mean speed of stream or speed of water. So now you, as a person sitting inside the boat who were going early with the speed SB in steady water, now if water also starts flowing in your direction, definitely you will realize the acceleration. That means your speed will increase. Now you will be moving with the increased speed. The speed now with which you will be moving is called as the SD. SD means downstream speed. So downstream speed, the name might be misleading. One might understand it is stream speed, because it says downstream speed. No, it is not the stream speed. Stream speed will still be SS. Stream is flowing with SS speed. Downstream speed is your speed now in the downstream. Downstream means whenever you are going in the same direction as the speed, when both go in the same direction, stream and you, in the person in the boat, that time, whatever speed you have is called as the downstream. And the value of which is going to be SB plus SS. Because earlier you were moving with SB. The boat is moving with stream is moving with SS along with you. So it is going to push you. So together your speed is going to be now SB plus SS. So this is the formula that we use. Downstream speed is SB plus SS. If water starts moving in the opposite direction with SS, then what happens? If now this water starts flowing in the opposite direction with SS. So now as a person sitting inside the boat, you naturally will feel the retardation. Your speed will reduce. The speed with which now you will be traveling is called as SU, upstream speed. So again, upstream speed is the speed you have when you travel opposite direction of the stream. So when they are traveling in opposite direction, you will be traveling with upstream speed, and the value of which is SB minus SS, because this time the water is going to oppose you. Your speed will reduce and you will be now traveling with SB minus SS. So there are two already formed formula we have. First formula we formed was SD is SB plus SS. This we call formula number 1. And SU is SB minus SS. This we call as the formula number 2. For next part, we can just add once these two. So left hand side will be SD plus SU. And in the right hand side, SS will get cancelled. What remains is 2SB. That gets us SB is equal to SD plus SU upon 2. This becomes the formula number 3 for us. And once we are going to subtract these two, from 1 we are going to subtract 2. So the left hand side will be SD minus SU. And on right hand side, SB will get cancelled. SS minus SS will be 2SS. And that gets us SS is equal to SD minus SU upon 2. This we call the formula number 4. So in boats and streams, there are these 4 formulas which we use to solve all the question. Of course, apart from that, we'll require one concept. But this is the formula number 1 for us. This is formula number 2 for us. This is formula number 3 for us. And this is formula number 4 for us. If you realize all these 4 formula in what situation they are to be used, you can then forget the boats, where are the boats going, where are the streams going. Just use these formulas. Okay, along with one situation, of course, that situation is again important, especially if you are targeting the exam like RBI Grade B. What the situation is, for this situation, you have to recall a little bit what we saw in the proportionality. And only one of the proportionalities. The proportionality that we saw, the proportionality number 1 was, if distance is constant, the ratio of the speeds is inverse of ratio of the time taken. In practical approach, if you say, I have to go same distance from my home to office, if I reduce my speed, the time I take will be more. That means this is the inverse proportion. By increasing one quantity, if another quantity is decreasing, that is called as the inverse proportion. And this is how you denote it. But how that is useful in this type of questions is, what happens is, sometimes it is given that you go certain distance in a boat and you come back the same distance in different time. Okay. So let's say this is the direction of the stream. So while going, your speed was ST because you are going along with the stream. That means your speed was ST, downstream speed. And the time you took was TD, time in downstream. But while coming back, you will be having opposite direction from the stream. That means you will be traveling with SU, upstream speed. And the time you take in this case, it says TU, time in upstream. So as you can see, the distance is constant in these cases. So for the exact same situation, when you go a certain distance and you come back exact distance, the distance will be same in both cases. And if distance is constant, speed 1 upon speed 2 will be time 2 upon time 1. That means downstream speed upon upstream speed will be upstream time upon downstream time. This also is an important concept because direct questions are asked based on this concept. Direct questions are asked. Of course, we'll see those questions as well. But those 4 formula that we have formed along with this concept, like time in speed in downstream upon upstream speed is equal to time in upstream upon time in downstream, but with certain condition. The condition is provided you are going the same distance both way. Okay. So let's solve some questions. Okay, let's see this. A boat running upstream takes 8 hours 48 minutes to cover certain distance. So the boat covers certain distance in 8 hours 48 minutes. 8 hours 48 minutes means we'll have to convert the 48 minutes also in terms of hours. So if you have to convert minutes into hours, you divide it with 60. 12 fours are 12 fives. So it is 8 complete and 4 by 5 hours. That means 44 by 5 hours. Basically, the upstream time is 44 by 5 hours. The time in upstream is 44 by 5 hours. While coming back, or in the downstream, or you can say coming back, it doesn't make any difference. So time in upstream is 4 hours, because this time you are running in the downstream. Sorry, time in downstream. While coming back, means time in downstream is 4 hours. So if I ask you, what is the ratio of SD upon SU? SD upon SU will be time in upstream upon time in downstream. Time in upstream is 44 upon 5. Time in downstream is 4. 4 11 times, that is 11 upon 5. So speed in downstream upon speed in upstream should be 11 upon 5. But they are asking what is the ratio of SB is to SS. What is the ratio of speed of boat and speed of current? SB is to SS. So you can just write their forms. SD is SB plus SS and SU is SB minus SS. And that ratio should be 11 upon 5. Do the cross multiplication and then you will see SB upon SS is coming out to be 8 upon 3. But of course, you don't have to do this all. Once you realize the form of the question, you can directly look for the options where, because see, what SD is sum of both and what SU is difference of both. And they're asking their ratio. So you just have to look for the option where sum of both and difference of both should be in the ratio 11:5. So naturally, 8 plus 3 is 11 and 8 minus 5 being 8 minus 3 being 5. That will give us the ratio 11:5 for addition and subtraction. That means this must be the ratio of SB and SS. So of course, this is how you have to work upon yourself. Once you realize all the concept or you understand all the concept, you're comfortable with it, then your next part of the practice should be towards reducing the time taken. So every question, you don't have to follow every step that we have been doing. You can skip the steps once you find it comfortable. Let's see one more. The respective ratio between the time taken by boat to travel same distance downstream and upstream, stream A and stream B, sorry, this time this is different. Stream A and stream B is 8:7. Speed of boat is 12 km per hour and speed of stream A is half the speed of stream B. So if I say speed of stream A is X, then speed of stream B is going to be 2X. And speed of boat is already given 12. So in stream A, the downstream speed of our boat is going to be addition of both speed of boat plus speed of stream. And in stream B, the downstream speed of our boat is going to be speed of boat in steady water plus speed of stream B. That is 12 plus 2X. They are saying the time taken to travel the same distance. Let's say the distance is d meters. So travel this much distance with this much speed. The time taken in stream A is going to be distance upon speed, because you are traveling with this speed and you have to cover this distance. And time taken to cover distance d in stream B will be distance upon speed with which you are traveling, that is 12 plus 2X. They have given this ratio as 8/7. This ratio they have given as 8/7. So you can just solve it. DD can get cancelled. The 12 plus 2X will go up. 12 plus X will stay down, is equal to 8/7. Doing cross multiplication, you will see this is 14X and 8X. Difference will be 6X is equal to 12. The X will be equal to 2. Just solve this. The X will come out to be 2. They're asking what is the speed of stream B. So speed of stream B, you just have to put 2 here. The answer will be 4. The answer here is going to be 4. I hope you got this. Let's see one more. Now, this is a good question, challenging, lengthy question that they ask in RBI Grade B. But of course, if you understand the concept, it's not that hard. Boat A travels downstream from point X to point Y in 3 hours. So let's say this is first of all the reverse surface. Point X to point Y, boat A is going to take 3 hours less than the time taken by boat B to go from Y to Z. So if this is say point X and this is say point Y. So boat A is going in this direction and it takes 3 hours less than another boat traveling from Y to Z. Now, boat A is traveling in downstream, but boat B goes from Y in upstream. Upstream means opposite direction of it. So first of all, boat B will be traveling in that direction. But where the point Z is, it is going from Y to Z. The distance between X and Y is 20. So this much distance here is given 20, which is half the distance between Y and Z. So you know, Z is in the left direction as compared to Y, and that distance should be double than distance between X, Y. That means Z should be beyond X. And this distance should be then again 20. Because it says so, the distance between X and Y is 20, which is half the distance between Y and Z. So Y and Z distance should be 40. Once you realize which point lies where, then the question is easy. You know the stream is flowing in this direction. Now it says speed of B in still water is 10. So this boat's speed of boat in steady water is given as 10. And speed of boat A in still water is equal to speed of boat B upstream. So let's say speed of stream is X. Speed of stream, let's say, is X. So for this boat, what is going to be the speed of boat in upstream for this boat? You know, that is speed of boat minus speed of stream, that is 10 minus X. They are saying for this boat, for boat A, speed of boat in steady water, SB speed of boat in steady water is equal to speed of boat B in upstream. So it is equal to this. So steady speed or steady water speed for boat A is going to be 10 minus X. So for this boat, what is the downstream speed? Because downstream speed is speed of boat in steady water plus speed of stream, which is X. That means 10. 10 kilometer per hour is going to be speed of boat A's downstream speed. Boat A's downstream speed. Now, how much time it will take to cross this 20 kilometer with this speed of 10? It is going to take obviously 2 hours because time is distance, which is 20 upon speed, which is 10. So boat A is going to take 2 hours, sorry, 2 hours, which is 3 hours less than boat B to travel from here to here. So that means boat B's time in its journey will be 5 hours. And again, time is distance upon speed. Distance is, this much distance is 40. Upon speed, speed will be speed in upstream because it is traveling in upstream direction. That means speed in upstream is 40 upon 5, that is 8 kilometer per hour. So the upstream speed of boat B is going to be 8 kilometer per hour. They are asking, what is the speed of boat A in still water? Speed of boat A in still water is also the same, 10 minus X. That means that also will be 8 kilometer per hour. So answer is going to be 8 kilometer per hour. So agree, not difficult, but a lengthy question. There are lots of situations are there in the exam hall. It becomes again more difficult to analyze like this. But again, we are talking about RBI Grade B, where you don't have to solve all the questions. You just have to pick the proper questions because the cutoff is as low as 7.5 and 8 out of 30. These type of questions, if you feel are lengthy, you can solve, but they are lengthy. They are going to cost me say 2, 3, 5, 4 minutes. Then totally you can leave these type of questions. Should not be part of your strategy. Unnecessary, because anyways you are going to get same 1 mark which you can get by solving the question like the previous one. If some question of that scale comes, definitely you should go for that. Okay. And if the question from boats and streams is difficult, definitely that one of the question from another topic will be easy as well. SSCI question might be easy in that particular year. So you should be, first of all, you should be covering basics for all the topics, because if easy question comes from another topic and you are not prepared for that topic, then it becomes difficult. So you should cover all the basics for all the topics, and then you should work upon picking the proper questions after that. Okay. Let's see one last question on this topic. Okay. Now this is a question from SBIPO, but it should be easy. A boat travels in upstream. The speed of boat in upstream is decreased by 40%. So you know, if upstream speed is to be decreased by 40%, we can say upfront the upstream speed is 10x. Now why I'm taking 10? Because it is easy to calculate 40% of 10. So I say speed of upstream speed is 10x. If you decrease it with 40%, it becomes 6x. And that is equal to the speed of current. Speed of current means SS. And speed of boat in still water, which is SB, is given 240 kilometers per hour. So you know, SU is SB minus SS. So 240 minus 6x should be equal to SU, which is 10x. That gets us 16x is equal to 240. X will be equal to 15. If x is 15, they're asking what is the upstream speed. Upstream speed means just put 15 here. Upstream speed will be 150. The answer here is going to be 150. Is it strictly formula based question? Don't even have to imagine boat is going where, what is upstream, what is downstream. Just use the formulas that we have derived. Okay. So I hope you found this topic interesting and easy. Thank you for watching this video. See you in the next session with some interesting topic. Till then, bye-bye. Have a good day.